All right, so we've been talking a little bit about the volume of prisms, and so this time we're going to look at triangular prisms. So with the rectangular prism, remember we were able to look at the area of the base, and we talked about stacking up, how many times can we stack it up. Now we're going to actually do something very similar for the volume of a triangular prism, because our formula is really going to be the same. The volume is going to equal the area of the base, and I'm going to say then times the height. So I'll put this in parentheses. So area of the base times the height. Now in this, we got to be a little careful about that word height, because when we're talking about triangles, we usually use height for this measurement right here, going from the top straight down to the bottom. But we're going to be careful when we think about that. We've got to find the area of the base. So we're going to start over here with this triangle. We can see this is a triangular prism. It has two bases. They are both triangles, okay? And they are congruent to each other. So we want to find the area of one. So I'm going to sort of imagine if I can find the area of this one down here. Imagine I'm kind of putting in a layer. So if we watched the last video about rectangular prisms, we kind of have a layer on the bottom. We're going to kind of fill in our first layer. Imagine if we kind of filled in just like a little layer, what it would look like. It's kind of filled in. And so we get to find the area of this base. So we can remember that the area of the base, the area of a triangle, is found by doing the base times the height divided by 2. Okay, so I'm going to have to take that. That's going to be my area. Base times height divided by 2. And when I'm saying height, I'm not going to talk about height of the whole prism. I'm just talking about the triangle. So I could even cover up everything else except for this triangle. Just think about the base and the height. So if I need to rotate it a little bit, remember, so this is my flat base. This line's going straight up and down. So that definitely works. So I'm going to find the area of that. So we're going to do the base of that triangle is 5. The height of it is 6. So I'm going to do 5 times 6. And then I would have to divide that by 2. Okay. So 5 times 6 would give me 30 divided by 2. And I'm just kind of showing my steps. 30 divided by 2 is going to be 15. So I know the area then of this, the area of the base, that's going to equal 15 centimeters squared. And then I'm going to take that, I'm going to put that back into my volume equation. Okay, area of the base times the height. So now I've done that. I'm thinking stacking little triangles. I filled in one. I have to stack another one on top and another one on top and another on top. I have 15 centimeters worth of them. So I'm going to take that area of the base. Let's go down here. Volume. That's going to equal 15 times this height, which also happens to be 15. And then if I was to do the math, 15 times 15, I would see that that works out to be about 225. Oh no, messed that up there. Sorry, 225 centimeters. I'm going to say cubed because it's volume. So that means this shape right here has a volume of 225 cubic centimeters. Now we're going to look at this triangular prism right here. We're going to notice it's a little different. This is where it's kind of tricky. We think about the base. This base of this, often when we think about base, we're like, oh, it's the part it's sitting on. But remember, base for polygons, for these 3D shapes, using polygons, we're going to have to look at the opposite sides. We're going to say, oh, if this is the base, that means it should have a congruent base on top if it's a prism. But it doesn't. We can see this lateral face right here. We got one there, we got one there. We got 3 lateral faces. You can only have 2 bases. So we're going to use this right here. This is going to be our triangle that we're going to find. So you can almost think about like you're taking this piece and you're flipping it upright, so it's kind of in a shape like this. So if you put the triangle down, that would be the base. So we're going to find the area of this triangle right here. So I'm going to use my equation. I'm going to do base times the height divided by 2. So let's see, we've got 10 times 3. Left to right this time. We have 10 times 3 divided by 2. That goes to 30 divided by 2. That goes to 15 centimeters squared. So we know the area of our base now is 15 square centimeters. So I'm going to put it back in my equation. Area of the base times the height. Now, remembering this is, even though it's kind of a depth dimension, it doesn't really look like it's height going up and down. we're imagining our shape. If we turn it so this is the base, we take that piece and we turn it upright, it's going to be about 8 centimeters tall. So we're going to say just right here, volume is going to equal the 15. Well, we'll put the units in there. You don't have to. 15 square centimeters times this third dimension, this 8 centimeters, this 8 right here. Okay, and so we would have 10 times, so we got 15 times 8. You can write your math over on the side if you want. 48 times 1 is 8, plus 4 is going to be 12. So that's going to give me 120 centimeters. And these are going to be cubic centimeters because it is a volume measurement. So we can see volume of triangular prisms, find the triangle, find the area of that triangle, and then multiply it by that third dimension. We can think of it as the height, and you're making stacks. Okay, or you can just remember it's the third number that you haven't used yet. All right.